Hey folks, welcome to Snowpal podcast. Our guest today is Michael Nappi. Michael is the Chief Product and Engineering Officer at ScienceLogic, where he leads a multifaceted team to deliver intelligent, scalable AI ops and agentic AI solutions. Michael, thanks for taking the time to chat.
Thanks for having me, Krish. Appreciate it.
My pleasure. We have a few topics, so we're going to start with one and then just let the conversation take us where it takes us in the next 45 minutes to an hour. Before we get into the topics, can you just give a quick intro about yourself, your background, and what you do currently?
Sure, happy to. So, as you mentioned, I run product and engineering at ScienceLogic, which is a leading AIOps platform provider in the industry. Um, Been here for about 7 years, running pretty much all aspects of R&D. Previous to this, I was at ServiceNow for 6 years. I started up and ran their ITOM division, doing IT operations management back in kind of the early years of the platform. And then previous to that, I was at Microsoft up in Redmond for about 16 years and ran a variety of different backend tools and server products. My two sons don't think I did anything meaningful because I never worked on Xbox, but I worked on just about everything else, it seems like.
Thank you very much. That's an incredible background. Very happy to have you here. Let's. I want to talk about a few different things, but just to get started, again, this is an opportunity for me and us as our audience to discover you and what you do as a person, right? So, we know very little about each other, which is the same with all of my guests for the most part. So, I'm very excited. But the first thing I want to ask you is AI ops. Can you kind of, as somebody who's been building software for several years, uh, think I know what it is? Not
Yeah.
exactly. So if you could sort of explain to us what AI ops is, and if you could draw a parallel, if it makes sense at all, to DevOps, for instance, that
Sure.
would be quite useful as well.
Yeah, well, if you take AI out of the equation, the ops part is really more specifically IT operations. So as long as we've had computers in businesses, there's been IT, for decades now. And the goal of IT and IT operations essentially is to ensure that all of the expensive capitalized assets that any organization has in terms of compute, storage, networking infrastructure is running and performing optimally and delivering service to the business. So there's been a whole slew of IT operations tools to achieve that objective over the decades. AI operations or AI ops represents kind of the latest turn of the crank. And the idea there is that you're taking all of this data exhaust that's coming out of an arbitrarily complex hybrid IT estate, and you're bringing that data together and you're having AI reason over the data to understand what's going on, separate the signal from the noise, and provide an insight around what humans should do to keep the infrastructure running optimally. So the AI part is really about using AI and similar techniques to understand what's going on in IT.
Okay, very well. So, who is your typical? I mean, a lot of my questions are going to be from my perspective as somebody who runs a small startup.
Mhm.
But your response doesn't have to relate to a startup necessarily, Michael. So, who is when you talk AI ops and the work that you currently do? What does a typical customer look like? I mean, are they like large companies, mid-sized companies, small companies? Like what do they look like, and what is the mix essentially?
Well, it's science logic anyway. We have been focused, the company's been around for about 20 years. It started off being primarily focused on large MSPs, okay, that are providing services to smaller businesses. And these large MSPs typically have very sophisticated requirements about being able to maintain multi-tenancy and provide services to a large number of enterprises. We also do, as you might expect, being based in Virginia, a lot of work with the federal government. We've done a lot of work with the DoD and civilian agencies throughout our history. Over the last several years, Krish, and part of the reason I was brought on board was to pivot the company more and more to Global 2000 enterprise. And so focusing on customers that have very large distributed hybrid IT estates and providing them with a single platform to understand everything that's going on across that distributed estate. So we tend to focus on the upper end of the customer spectrum. It's typically larger enterprises, large MSPs.
Perfect. So, so by MSPs, you mean managed service providers who are building software for other companies, essentially, correct?
Well, and in particular, they're hosting IT operations management on behalf of other companies. So they're providing monitoring as a service, for example, to smaller businesses.
Wow, okay, I understand. So they are specialized in the type of service, software service that they are providing to their customers, and those are the folks, the companies that you actually work with, essentially. Okay, I think I'm
Yep.
getting a sense here. So what are, if you could take an example, a real life example of maybe an existing, maybe it doesn't have to be an existing customer, it could be a creative one as well. Sort of walk us through what are the types of features or services that they require from those MSPs, particularly from the perspective of what you're able to help those MSPs with. So, in other words, let's say this customer goes to the MSP, they need to get 10 things done. We can ignore the two or three things that they might do for them that don't relate to our conversation here. But
Yeah.
if you could take some of those important things that you are able to help them with, that will be a good place for me to start understanding and discovering what you do.
Sure. Well, first off, if you look at the managed service provider, what they're being paid to do is to essentially manage a customer's IT infrastructure, their compute, storage, networking infrastructure, and essentially provide monitoring on that infrastructure, ensure that the infrastructure is available, it's up, it's running. If anything happens on that infrastructure, if you lose a server or a service or something like that, the responsibility of the MSP is to remediate that issue, get the service back up and running. So really what customers are buying from the MSP is available IT services, okay? What we provide at ScienceLogic is a platform for MSPs and also large customers to do that. And so our platform has a number of different capabilities, but one of them is, first off, you can't manage what you don't know about. So the platform goes out and detects everything that you have in this arbitrarily complex IT estate. It brings all that information back into a common kind of data lake, and then it reasons over that data and gives you insight into what are the set of things across, let's just say hypothetically, a 20,000 server environment. What are the things that you need to pay attention to from an IT professional standpoint? And then it also provides guidance around if something is going wrong, how you might go about resolving it. And then we also have automation in our platform that allows you to actually take action and go remediate the issue automatically.
Wow, that's a lot there. I was just making quick notes here. Thank you for laying that out. That's very helpful. And now I think I'm getting a fair sense. So just to recap and correct me if I'm wrong, where I'm wrong here, Michael. So these large enterprises go to these managed service providers to help them with managing their IT infrastructure, right? That's the core problem. For those companies to manage their IT infrastructure, they rely on your product. So you're a product company that's providing these products that those MSPs can actually use to provide services to their end users. Did I get most of it correct there?
Yep, that's right, Krish. Yep.
Okay. So your products are transparent to the customers that are working with those MSPs, correct? From an MSP customer relationship standpoint, they are doing a phenomenal job, but how they're doing it and where you come into play is kind of transparent to those end customers.
It is to a degree, to a varying degree. We have the idea of role-based access controls in our platform. So the MSP, for example, can take the role of an administrator and do essentially anything they want on the platform. They may delegate some permissions to the end customer. So the end customer can come in and look at their devices and look at their services that are managed by ScienceLogic and understand what they should be paying attention to. And so, in that sense, the end customer, Krish, would actually be interacting with our product. They would find themselves in a ScienceLogic UI, for example. It's just they may not have permissions to take certain actions depending on what sort of policies in place with the MSP.
Perfect. You explained that beautifully. So it's kind of clear in my mind. So at least now I know a little bit more to ask you a few hopefully meaningful questions here. So I think people are watching this probably have caught up. The reason I recap some of this is for me to digest it and also to make sure people who are listening also have that understanding.
Mm-hmm.
Uh, Great. Now a customer comes to this MSP. Let's call it MSP one. They like, you know what, to make their lives better and easier, they're leveraging the products that ScienceLogic offers, and you're managing the larger team there. Now, to get into the details of some of this, you mentioned these number of servers. You mentioned a number of important points here. You said uptime is important, right? That's critical, right? You want to provide all of this uptime. So
Right.
I want to start with one of my questions there. Now, you're the customer that's actually working with the MSP that's in turn using your products. Uh, they might be on any of these cloud platforms. I'm just saying platforms just to start this is my question. Say they are on Azure versus Google Cloud or AWS, which means your products are, I'm presuming, agnostic to these hyperscalers, right? Michael, they kind of support one or more of these platforms. Is that right?
That's correct. Well, there's two aspects maybe to that question. First off, ScienceLogic's platform itself is agnostic, deployment agnostic, meaning you can deploy it on-prem. You can actually run it on physical or virtual hardware that the customer has on premise. You can more typically have ScienceLogic provide these capabilities to you, the MSP, via our own SaaS offering. So we can host it on your behalf. And then we can also host it in a MSP's cloud of their choice. So if they have an account in Azure or GCP or Amazon or whatever, they can be deploying ScienceLogic in there as well. And then in terms of what we monitor of the workloads that a customer might have, we can look into any of those hyperscaler environments. So if you have an application that runs in Azure and another one that runs in GCP, we can monitor both of those, and you'd still see everything through kind of a single pane of glass.
Okay, so there's two parts to it. Let's get into each of those. The first one's a little bit easier than the second, but I'll start with the first one. You
Yep.
mentioned that they either run it on-prem or if you could run it on any of the cloud providers of their choice, essentially, right?
Yep.
But where do you see, this? I ask this because there are these three large providers, as we all know. AWS the largest, and I think probably followed by Azure, and then Google Cloud. I think Google Cloud probably has been gaining a lot more traction. And then you have a lot of these neo clouds as well. So, given all of this, in the last year or two, Michael, where do you see a lot of this support and demand being? Is it one of these cloud servers, or what has been your experience there with where you've seen people ask for your services to be deployed onto?
Well, again, in terms of what customers want to monitor and where they want to monitor, we're seeing really all those clouds. And typically, for most of our larger customers, they have workloads on multiple clouds. They're not 100% in on AWS, for example. They might have some workloads on Azure as well. And so the main thing for us as a platform provider is to be able to provide observability, visibility, no matter where the workload is hosted. So it can be on-prem, it can be virtual, it can be one of the hyperscaler clouds. We don't care. It could be in VMware, it could be in Broadcom. We don't care. So we can, wherever your workloads are, we can find them, we can detect them, we can understand their health in real time.
Okay, makes sense. And then let's say let's take an example of where the MSP is using your cloud service, just to keep that conversation small and focused there. So they have a new customer that's signed up for their service. The onboarding of that new customer onto your platform, I'm just slowly trying to walk through to understand this whole system here. To
Okay.
onboard onto your platform, does the MSP do it for that customer, or do you do it for the MSP for that customer, or does the customer, because they have some insights into this, do some part of that onboarding themselves directly
Yeah.
onto the provider through your platform?
Yeah. Yeah, it gets interesting because there's a variety of different flavors of the way that things could be deployed. But let's take the simple case and the more common case. For most MSPs, they would like ScienceLogic to host our platform on their behalf. So we onboard an MSP, first of all, into ScienceLogic's SaaS environment. And we run and operate ScienceLogic on behalf of the MSP. Okay? And then the MSP in turn goes out and acquires customers for their platform, which happens to be hosted by ScienceLogic. So it's kind of a Russian doll type of thing. I mean, it's
Okay. No,
contained,
no, I see.
but
I
you
s-
know what I'm saying.
no, no, I see what you mean. So let's say, let me get a little bit further there. Let's say you have two MSPs that you're working with,
Uh-huh.
and there's a process to onboard a third MSP. But let's say you have two MSPs at any given point that are working with ScienceLogic, and
Right.
the MSP has the integration done with you, right? Whatever that onboarding entails, like let's say the new MSP, MSP3, they work with Michael and Michael's team, and then they get everything onboarded. Now I'm guessing there's a set of things that they need to do to onboard onto your platform for the first time. But when they as your customers acquire more customers, that process is going to probably be a whole lot smoother and faster and quicker than the very first time that they onboarded onto your platform. Is that a right thing to say?
That's right. So there's a few different components here. So when we acquire a new customer on our SaaS, on our cloud, okay, so they're run and operated by our SRE team. Then SRE will provision a new instance in our cloud for, let's say, customer A. And what that means is actually installing on some cloud-based infrastructure the ScienceLogic Skylar One product. That's our flagship product, okay, for doing observability. So we install that on a set of virtual machines, in essence, in the cloud, and we then we configure that instance for the particular MSP for this new customer, right? And by configure, I mean we fine tune it, we understand how much scale they have, and we deploy a set of collectors, for example, to understand their environment and bring back that information. We understand what kind of technologies they're talking to because we have this extensibility model called Power Packs that allows us to talk to different types of technologies in an IT environment, okay? And so we do a bunch of work to get that MSP onboarded onto the ScienceLogic cloud, call it that, okay? And then once that's set up, the MSP can go out and acquire new customers that are running on their instance, and it's multi-tenanted, right? So each one of those customers is its own tenant within the broader platform that this MSP has that's being hosted by ScienceLogic. And really, the onboarding effort there is pretty straightforward. The MSP would deploy a set of ScienceLogic collectors that the customer, the end customer, would install in their environment. Those collectors allow ScienceLogic to essentially talk to their environment and understand what they have and bring it back into the MSP's kind of central service. And then the MSP would provision whoever the users will be in the customer environment that'll be interacting with the platform. So hopefully that was somewhat clear, but
No, no, it was. I'm going to ask you. You talk about the collectors there.
yeah.
Uh, what are those collectors? I'm going to ask you. I'm going to share a little bit about what we do as well. Now, sure, we are a smaller organization, but we have a fair number of products even in our ecosystem. So
Mm-hmm.
I'm just extrapolating what we do to times 100 or times 1,000, for instance, to get the size of the problem we are most likely solving here. But let's talk about the collectors. What are those collectors, and can you give us an example of what they are, and how does the customer install those collectors in their ecosystem?
Yeah, they're simple to install. It's essentially it's a Linux application that you install. You set up either a virtual or physical machine. We have certain hardware requirements. And then just like any other application, you install it. And the collector is kind of a self-contained appliance, ScienceLogic appliance. And what it does essentially then runs out on your network and understands everything connected to that network. And the collector can support hundreds of endpoint devices and network gear and everything else. And it brings all that information back. The collector has its own state, so it acts as both a cache and a persistent storage for what the collector is aware of, and then it forwards that state to the mothership, if you will, which is the ScienceLogic platform. And it's like, here's everything that I found, and here's the relative health of everything that I found. And so we have this
Okay.
kind of distributed collection architecture. And the collector allows these things to sit behind the customer firewall. And then from a security standpoint, there's no issues with communication back and forth out of that firewall.
And and the reason I have a few questions about the collector, Michael, but the reason the collector is actually installed in the customer environment, is it purely because of firewall reasons? I mean, is it because otherwise it could potentially be running on the ScienceLogic side to doing whatever it is doing, right? But is the reason for it to actually be running in their network because that surely the customer does not want there's things that are in the DMZ, so they don't want access to all of their or any of their systems from outside. Is that the reason why the collectors are installed in their network?
Yeah, there's a variety of different reasons for it, Krish. Some of them date back to uh, doing a lot of work, as we've done in the past with the federal government, oftentimes in air-gapped networks. And the idea is that you want to have kind of a store and forward architecture that allows you to have something that's sitting in the customer site that's collecting all the telemetry. And then the next time there's communication established to the mothership, it forwards everything that it's got. So you can think of it as like kind of an edge cache in that regard. And so it provides just additional resiliency um, for for a
No,
variety.
no, it makes sense. The only reason I ask that is, see, I can see if it's the DoD or if it's a government related system, then there's a lot more security that you cannot possibly even architecturally have this outside. But if it's a non-governmental entity,
Yep.
say, then would that be sort of not a hiccup, but it makes it one step more difficult to complete the onboarding as opposed to if the collectors were to be running on the ScienceLogic side. You know what I mean, right? So for a non-government customer, are there still other reasons why this should actually be running something that they need to install in their side?
Yeah, yeah. The collector is just one part of the architecture, and there's other ways of pulling the infrastructure that we can get to depending on the customer's particular use case.
Okay, and then once these collectors are installed, how do they? Looks like one of the first things or one of the initial things that they're possibly doing is discovering everything that they should be interested in. So, what are some of those things that they're discovering in say, a typical organization that they're being installed in?
Yeah, I mean, really, it's anything with an IP address, to put it simply. So um, we have, as I mentioned earlier, we have this extensibility model that we've developed that allows us to define a technology in terms of how do we want to communicate with that technology over what kind of protocol, SSH, SNMP, you know, APIs, et cetera. More recently, MCP. But whatever the protocol happens to be, how do we want to monitor that technology? What sort of thresholds do we want to set? Because you don't want to take everything back necessarily. And then how do you even want to visualize the technology in ScienceLogic? So you can actually describe the presentation layer as well. And so it's a pretty powerful set of extensibility to the platform, because while we ship hundreds and hundreds of these power packs with the platform, there's always new technology that comes up. And so a real power of the ScienceLogic platform is the ability for our customers to build their own power packs for any customer bespoke technology that they have. And then increasingly, you can do that using no code, low code techniques. And then very recently, we announced the ability to do that using natural language. So it's essentially generative AI that creates a power pack for you. So it's very powerful because any large global 2000 enterprise has not only modern technologies, but they got a long tail of legacy technologies that are never going to be touched because nobody knows what those things are doing. The person who originally used them left. And so it's just there. Nobody wants to touch it, but you still have to monitor it. And so we have uh, probably the richest coverage in terms of IT technology that's out there.
Wow. And you said a number of things there, Michael, but two that caught my attention because we are kind of in that business. You mentioned APIs and MCP, right? So one of the things we do at Snowpal is we build these APIs, make them available for other businesses, smaller businesses to build software in quick time. That's the gist of it, and we are working on providing an MCP layer on atop all of these APIs. So let
Mhm.
me take that as an example to ask the next set of things I want to ask you here. Say our APIs are currently, deployed on AWS Marketplace, right? So
Mhm.
they are available on AWS Marketplace, but they are using a number of different AWS services. Each API is different from the other. They provide a particular value, whether it's horizontal or if it's a vertical API, whether it's industry specific or domain agnostic, and the dependencies are largely different from one to the other. So let's say that's, I think, a decent enough example. So let's say we now have this collector that you mentioned, and if we potentially integrated, let's say we wanted to leverage ScienceLogic to be able to manage some of these APIs or all of these APIs. Some have dependencies on AWS, some have dependencies on Salesforce and Heroku and whatnot. As you imagine, every customer is different, all our dependencies are different. Some of them use MongoDB, some use MongoDB Atlas, some others don't use MongoDB, like they use different databases, and we're starting to use vector databases, for instance. So I just threw a bunch of things that we are currently using.
Yeah.
How would we go about, let's say we took this collector, how would we go about setting this up so the collector is able to discover that, hey, at Snowpal, these are all the APIs, these are the MCP servers, these are all the database dependencies that they have, some running on-prem. In our case, it's not, but hypothetically,
Yeah.
some running on the cloud, for instance. There's going to be a rich list of this that they're discovering. If you could just walk us through that, that'd be amazing.
Well, look, the collector is just an implementation detail. It's a means to an end. So I wouldn't even worry about the collector. That's just how things get deployed in the architecture. The power pack, which I alluded to earlier, is the way that you describe what it is you want to talk to, what it is you want to collect data from. And so what we'd be doing, Krish, is building a power pack that is specific to the APIs that you're talking about and would just communicate directly through those APIs, collect whatever data is available behind those APIs, and then bring it into ScienceLogic in the way that you specify.
Okay, so I mentioned a few services there, right? We use say we use the AWS API gateway, we use Cloud Formation, and I know a bunch of other DynamoDB and whatnot.
Yep.
So ultimately, after it discovers each of these, the idea, as you mentioned, if I understood correctly, Michael, was for the collector to first identify these dependencies. What does this ecosystem comprise of? And
Yep.
then send this to the mothership. So, what kind of information is it potentially sending in the case? Like in my example of, say, DynamoDB, or I don't know, DocumentDB,
Yep.
API Gateway, and CloudFormation, and a bunch of other AWS services. What is it trying to collect from those services to send to the mothership here?
Yeah. Oftentimes in AWS services, there's telemetry information that comes out of those services, either via CloudTrail or some other service that Amazon provides, or the service itself provides telemetry data, metrics data, event data, trace data in the case of applications. All that data can be brought into ScienceLogic and reasoned over, correlated, deduped, normalized, et cetera, and then used as the foundation for our monitoring platform.
Okay, just trying to understand that even more, if that makes sense. The thing I'm trying to understand is, you mentioned uptime as one of those things, but when a customer is using these large cloud providers, you're not necessarily worried as a customer about the uptime because AWS promises 99.99% uptime. So,
Right.
so the value that I'm presuming that Science Logic would bring to the table, one of the many things that it's going to bring to the table, Michael, would be not just the uptime, right, but the collection of everything. In other words, a customer has dependencies all over the place, and even if each of those providers provide enough confidence in terms of uptime and whatnot, I'm guessing that the reason people are using a third party provider or a platform such as yours is because they want somebody to manage their ecosystem in totality, right? Not in isolation.
That's
If they
right.
could be using AWS, Google Cloud, and other neo clouds, I mean, am I saying that more or less correctly that their need here is to manage their ecosystem or infrastructure in entirety, as opposed to just believing that each of those provide 100% uptime?
That's right. Yeah. And again, availability is only one, use case. It's, as you point out, more applicable for a virtualized environment that's self-hosted, right? Versus a hyperscaler where you just take that stuff for granted. But, fundamentally, the hosting environment and the technology itself is all a means to an end. And what's the end? The end is the service you're providing back to the business, whatever that happens to be, right? This could be a order to cash service, could be a website, could be whatever, line of business system. One of the things that we do in the ScienceLogic platform is we take all that infrastructure, right, independent of where it's hosted, how it's hosted, and we can map that infrastructure to the service that's being delivered to the business. And so we have, and this is something we've been investing in particular for the last several years, is we can provide this service mapping capability in real time. It's dynamic, and it allows you to see the health, the availability, and the risk associated with the performance of a service, whatever that service happens to be. And then if that, we can render essentially a health check on the service and tell you that the service is trending south, meaning the availability is going down for some reason, or the performance from an end user perspective is getting worse. There's more latency. And so as a IT professional or an MSP, you could see, hey, that service was green and now it's trending to yellow. I need to figure out what's going on with that service. And then you can double click into the service and you can see all the hosting details, that including talking to Amazon DynamoDB or whatever other things you've got underneath the service. And you can drill in and try and isolate what is the root cause of the issue creating a potential service availability problem. And that's really what you want to get to. In fact, you want to not only react to issues that are happening, but you ideally want to get ahead of an issue before it happens, like see trends that are indicating there might be a future issue that could bring the service down, and ideally interact proactively.
Makes sense. And I think that's a good segue to taking it going outside of the collectors. I was just talking about us as a customer, potential customer, getting the collectors, having that installed, and having it do the discoverability and sending data back to your system. So I think I've gotten some understanding there. So we could use what you said there to get into the second part of this, which is now that it's been installed and it's collecting data. And I'm guessing, is it sending data in real time? I'm presuming it is sending data in real time contiguously to that mothership. Is that right, Michael?
It varies, to be honest, based on the interface. Sometimes it's polling, sometimes it's real time. And we do that for efficiency's sake, so that you don't flood the system with a whole bunch of noise that's not useful. I mean, some telemetry is highly noisy, like log data, for example. You don't necessarily want to take all of that. You want to do some filtering on that, or you want to take samples of the data. And so the short answer to your question, Krish, is it varies.
It varies?
We have the ability to do real time.
But is it what protocol does that use? Is it like WebSockets or HTTPS, or how is the data being sent from inside to your system?
Yes. Everything you just mentioned. So I mean,
okay, got it.
We're protocol agnostic by design. So I mean that Power Pack thing that I describes the protocol by which you're actually ingesting the data. So
and then sure, that makes sense. So the data is being sent, let's say WebSockets, HTTPS, doesn't matter. The data is being sent to your system. You're collecting the things that you do want to collect, but let's say you're collecting metadata, right? You're collecting metadata about those systems and services that the collector has been able to discover. And where and you said it's multi-tenancy, so you're storing all of that metadata on your side, for instance, right? So I just want to talk about the persistence for a minute or two. Where is this getting stored? Is that stored in like a traditional database? Is it like RDBMS, NoSQL, Vector? Like what kind of storage system is it being stored in?
Well, again, it depends on the deployment model. We're very flexible on deployments, as I mentioned earlier. So if you're self-hosting ScienceLogic and it's running in your own environment, it's storing in a RDBMS. I mean, it's a SQL-based data store, essentially, at the end of the day, relational data store. If you're running in Amazon hosted by ScienceLogic, you're in Aurora, right? So it's, and we take advantage of some of the storage services that are available so we can scale up and down, et cetera.
Makes sense. So if we are running it, you said it's RDBMS. So do we as a customer get to pick whether it's Oracle, Postgres, or something else? It does not matter which database it is.
No, we're fairly specific. I mean, the entire platform runs like an appliance. I mean, it's very self-contained so that we can manage the interdependencies and ensure
Oh, I got it. So whatever, so it might in turn be using Postgres or something else, but whatever it is using within
yeah,
the appliance is what we end up using it, right? Okay, got it.
yeah, yeah,
So it stores this data, and I think I get a sense. So that's how you manage what's going on, right? The data is being sent every so often, maybe in real time, it's getting stored via this appliance into its storage systems. That way, however, the reason I asked was it's a moot point, but I was just trying to understand how if that data is something that we as a customer would manage, but not so much, right? It's data part of the appliance. It's the data structure and how it's being stored is kind of transparent to us as a customer. It's only available to your appliance, so it knows what to do with that data.
that's right.
Now you also mentioned visually being able to see which systems are up, down, or turning yellow, so you need to react to them. So I want to just ask a few things related to that. Now let's say even in my example of a few services that we are using, some at, say on I mentioned AWS, but we use a couple of services on Google Cloud and Azure as well. So we have this nice diagram or this visual representation of all of the dependencies. The first thing I want to ask is, let's say if the customer has 50 things that they are leveraging, they may or may not have ScienceLogic discover or monitor all of those 50 for many reasons. One could be just the cost, right? I'm presuming there's a pricing model and the cost is going to increase based on how many services that ScienceLogic is going to monitor. So they might have some reasons to pick which ones they want to be monitored. Maybe the weakest link in the chain or the ones that they have the least control over or whatnot. But let's say once they pick, when you go through the process of picking which ones you want to actually have ScienceLogic monitor,
Yeah.
that activity is happening on your platform, right? So somebody who has that particular role is going to look at that ScienceLogic page that gives me all the hundreds of servers and services, and then do we go pick and choose which ones we particularly want, Michael?
Well, the typical deployment is most of our customers are trying to modernize their IT infrastructure. They typically have 15 to 20 to 30 different element managers in place they've acquired over the years to manage different aspects of that infrastructure. They buy ScienceLogic because they want to modernize and consolidate, and we are kind of one ring to rule them all. I mean, that's the platform value proposition is directly correlated to how many legacy tools we displace. And you go to a single consistent platform, a single consistent extensibility story, everything. So most of our customers are buying ScienceLogic for managing the entirety of their IT estate. It's not to say there aren't pockets that are bespoke and there's mainframe and there's other things. And then typically we have an integration with them, which you had asked earlier, Krish, about like the data is kind of opaque to the end user from the standpoint that it's used by ScienceLogic and bubbled up through dashboards and that sort of thing, but they don't actually pay attention to the storage mechanism underneath. But that said, we do have APIs and we have workflow integration that is possible to federate all the data that we collect to third-party endpoints. And so we do that quite a bit. One of those endpoints that we see quite a bit, as you might imagine, is ServiceNow. A lot of people want to use ServiceNow as the help desk, the ITSM platform. And ScienceLogic provides that real-time view of all the infrastructure to fuel their CMDB and drive incident management, for example. So We have a very rich bidirectional integration between our platform and ServiceNow for that. But getting back to your question, the data that we collect is typically across the entirety of the IT estate, typically. And then that data is accessible via a number of means, including API, workflow automation, integration, and so forth.
Interesting. I promise you, Michael, we never talk about specific products and services on our podcast because the idea is less to pitch but more to understand the business. The
Yeah,
only reason I'm going back specifically to your product is actually interesting. To me, I'm taking your product as an example for me to understanding the business problem.
yeah,
But thank you for explaining this. So let's say that makes sense. Now you people are able to monitor, they pick and choose what they want to monitor. I have a few things to ask there, but I want to understand the modernization part because my takeaway so far, for the most part, has been that you man help these large companies manage their systems, which are pretty complex and they have dependencies all over the place. So you're able to tell them, give them an insight and a visual, they're able to visualize or see it in a visual manner as well as to what's happening, which part of the systems are more stable than others, and how they need to react or be proactive to some of those things. That to me, I took that as you help them manage what they have, but how does that necessarily modernize what they have? Because if I'm running a COBOL based system from like 100 years ago, sure, ScienceLogic is going to tell me, hey, Krish, your system is working well or it does not work well. But how does it help me get out of that legacy system?
well, there's different facets to modernization. What I was specifically referring to, Krish, is modernizing their IT infrastructure observability platform. And
Got it. Got it.
and honestly, we go into customers all the time and we ask them what kind of technologies they're using today to manage their very large IT estate. And I've gotten this answer more than once. I have one of everything that's ever been made. They literally have tried every tool that's ever been made, and it's all sitting around in little pockets of their estate. And maybe they've acquired companies, and that company uses one set of tools, and then another company uses another set of tools. Anyway, it's a mess. From a standardization standpoint, it's a mess. Everybody's speaking a different language. And so one of the value props we bring in is as part of a transformation modernization effort that the company may have, we can displace all those legacy tools with a single consistent platform across their entire estate. Now, the individual workloads, as you put it, might be running COBOL, whatever. I mean, we don't get down to the application layer and transform that. That's the DevOps side.
No, that makes sense. And I think in my past life, Michael, I used to work for large companies, like really large ones. And I know when they acquire these other companies, sometimes large companies as well, or sometimes every week there's an acquisition. It doesn't come in the news because they have so much money and they keep acquiring. And what happens when you're working in those organizations, at least from my experience, and my experience is you see that there's like 17 versions of the exact same thing or something that's very similar. It's
Right.
because not every acquisition ends in beautiful integration necessarily. Sometimes these systems end up living in silo till the end of time, till somebody pulls the plug on one of them. So I can actually see, if let's say we were to theoretically use something like ScienceLogic, and it shows me this diagram of everything that we're using as a company. And if it shows me like 7 different databases for what we do,
Right.
yes, your core idea was not necessarily to help us modernize that, but if you give enough visibility to the user as to what's going on, now if somebody sees this, hey, why in the world would you have 7 databases? Can you not have like one or two of them? At
Sure.
least it
Yep.
gets you thinking. So maybe it gives you an idea to start not necessarily modernizing in this case, but maybe more streamlining, right? Doing things better than how they've done in the past.
Yeah, absolutely. And we help customers understand, first of all, everything they have. A lot of times customers have no idea. Like they had no idea they had some of this technology and they actually find it and they go, wow, we should get rid of that or we should standardize. So it helps to inform a lot of those kinds of things, standardization and capacity management, other types of use cases as well.
Okay, and the last part of this I want to talk about, right? We have about 15 minutes to go. I'm going to let you ask any questions if you have any for me as well. But let's say as we've gotten, what is the last leg of this is the callback mechanisms. Let's say we've used this, we started integrating with ScienceLogic as a platform. It's starting to read the data. The collectors are sending data every so often. You persist the data, the appliance is making sense of the data, showing us beautiful charts and whatnot. And you mentioned being able to react to things and being proactive as well. So how does it send information back to us as customers? Do we register callbacks? Like what are some methods that we can get data back from Science Logic outside of going to the user interface and looking at it manually?
Well, there's a number of different mechanisms for doing that. A couple of them I mentioned earlier, like a lot of customers live in an ITSM platform, right? And they work on incidents that are coming out of some sort of monitoring or observability tool. We can create incidents in something like ServiceNow, for example, and that gets routed through its whatever the workflow is that the customer has. We can light up a notification in Slack, for example. We can light up a notification in PagerDuty. We can send information into Jira, create a Jira ticket. So we can send a notification out of ScienceLogic to wherever the customer lives, wherever they're actually acting on insights that are coming out of the IT environment. So that's a core aspect of the platform, is that being able to do notifications and alerting to wherever a customer endpoint happens to be.
Makes sense. You mentioned a few things there, but let's say if we have a way to, we want to be notified of things that are happening. So can we register like endpoints or callbacks on your site so you actually send data back to us through our callbacks?
Well, the callback, so maybe this is a taxonomy thing, but the payload that goes to these endpoints can be arbitrarily rich. Typically, what we do is we send an alert that's created and curated by ScienceLogic, and it has a rich amount of context around it, like when the thing happened, what the thing is likely related to. And so wherever the receiver is, wherever the endpoint is, the payload they get from ScienceLogic is highly actionable. There's a lot of metadata and direct data, including log data, around what's going on and what to go do about it. They can then prosecute the incident according to whatever workflow is set up. It could be an incident, it could be something in Slack, it could be a DevOps thing that's running through Jira, whatever it happens to be, we don't care.
Makes sense. So the reason I asked that is, let's say I was just thinking about registering an endpoint that's a Snowpal endpoint that
Yep.
says, you know what, if such a thing happened, right? Let's say there's 25 different things we are specifically interested in. I could
Yep.
say that if these three things happen, call this particular endpoint, and we provide the API key to you on ScienceLogic, and you send the payload to us, and then we internally can do whatever we want to do with that payload to react to this information that's coming from ScienceLogic. So
Yep.
that structure, that rich the message structure you mentioned, would that in this case be like a JSON payload, Michael?
Sure, it could be. We have a technology that we call PowerFlow, which is a general purpose integration workflow engine. And that PowerFlow orchestration engine can essentially talk to any arbitrary set of systems and deliver any sort of transformation you want on data that's coming out of ScienceLogic's environment. And so it's a very powerful tool, no code, low code. You can do drag and drop onto a kind of a Visio-like service. And a non-developer can stitch together a workflow that describes how I want to notify some endpoint or call some endpoint under what conditions, et cetera, and then publish that workflow, and it's in production. It's already set up. So it's a very powerful tool.
Makes sense. And then this exchange of data that we're talking about here, right?
Yep.
The payload that you send in the event something bad is going to happen or has happened, so we react to it. Is there an industry specification that dictates the schema of these exchanges, or is that proprietary? The data structure that's coming to us, is that specific and proprietary to ScienceLogic?
Well, it's not so much proprietary to ScienceLogic. It's just the form that we transform the data into is dependent on the endpoint it's going to. So ServiceNow, for example, has an incident template. And so we would populate our alert into that incident template. So ServiceNow provides the schema that we would talk into, and every other endpoint has kind of their own equivalent to that. So
Okay. And then one of the last things I want to ask is, so there are a number of these providers or systems, right? You're talking about the world out here. In other words, a customer could be using, I don't know, like us using a bunch of services in AWS and some on cloud and Azure. Sure, a lot of the customers are using these hyperscalers, but in the last year or two, we've seen a lot of these neo clouds come into play, and a lot of people are using it. Us, we are, as somebody who's been using AWS for many years, Michael, we almost all the time look at CoreWeave and Nebius to see, because the way you can integrate with these AI services is a lot easier sometimes on these neo cloud platforms than the hyperscalers. The
Yep.
point I'm trying to make here is that the number of those services is just, given that there's so much money in that space and so much is being spent, there's going to be a proliferation of these tools and platforms. So, is that a challenge for a company like ScienceLogic to actually be on top of? Because it's not just three big companies that all, I mean, not that they don't have a large catalog themselves, there's
Right.
also more companies. So now we have existing providers with an increasing list of AWS products and services in their catalog, and you have more companies. How do you as a company manage, because there's only so many plugins I'm presuming you can create, how do you create them in quick time?
Well, you're absolutely right. There's no way you can do it. You can keep up as a single provider. And so for some time now, we've admitted that. And Power Packs, again, is our extensibility model. We have something kind of symmetric to that called Sync Packs that describes how you want to automate a technology. But for monitoring a technology, Power Pack is the extensibility object. We ship a bunch of these out of the box. But more importantly, we created an IDE called ScienceLogic Skylar One Studio that essentially allows you to build your own Power Pack for anything. So, I mean, if you're using CoreWeave, you're using some of these bespoke clouds and so forth, we may not have it out of the box, but you could build your own. And increasingly, that build your own is literally natural language. You tell Claude Code what it is you want to build, and it'll spit out essentially something based on our formatting principles in MCP.
Oh, that's interesting. So, in other words, the customer is not necessarily limited to the integrations that you currently support. If there are integrations that you don't support, you have a way for them to build these new integrations for them to be able to use.
Yeah, that's right. But
That's okay.
so one thing before we break here, Krish, and I appreciate all the questions, but a lot of this stuff, frankly, is going to be yesterday's technology because one of the things we are very proud of at ScienceLogic is we've implemented a new platform that works hand in glove with our flagship observability platform that we call Skylar AI. And we believe Skylar is going to be absolutely game changing because instead of going out there and trying to understand everything that's going on in your complex environment, Skylar takes all those signals behind the scenes, correlates them, dedupes them, and does inferencing on them using a proprietary domain specific large language model that we have embedded in it and our own context engine and informed by all the technology that we've developed over the last 20 years. And we essentially create a highly proactive, guided AI experience. So the idea, Chris, is you grab your cup of coffee in the morning, you sit down in front of Skylar. Skylar knows you because it knows how you've interacted with it in the past. It says, Krish, out of everything that's been going on in our environment for the last 24 hours, here's the three things that you need to pay attention to. And when you bring it up, it'll summarize them. It'll show you the likely root cause based on tons of different telemetry data. And it'll give you some quick prompts that allow you to take action and actually go remediate the issue. Or Skylar can invoke an agent that'll do that automatically for you. So the AI part of this is absolutely transformative. We didn't talk a lot about it today, but I wanted to make sure that I got that in there because it's a game changer.
No, very important. Our audience is predominantly technical, so they're going to want to know this from you, Michael. Your engineering team, what are some of the AI tools that they're currently using to make themselves more productive? Outside of like Claude and say ChatGPT and Codex, if you could just share with us some of the tools that they're using and maybe even how to help themselves become more productive, that'd
Yeah.
be quite helpful to us.
Yeah, I'd say for the past year, we've been, like many companies, experimenting with a variety of different frontier models and, coding models to accelerate our ability to do coding, augment code, create new features in code, test automation, a variety of different things. This year, since the beginning of the year, we've been embarking on something that's much more transformative If you've worked with AWS at all, you know they have a new framework they've recently launched called AI DLC. There's other there's other frameworks that are out there, but the idea is AI becomes intrinsic to the development lifecycle. It's not something that you just consult and have do some code generation for you on the fly when you need it. Instead, you use the AI as almost a digital component of your Scrum team. And you work with the Scrum team in very, very short bursts that, as opposed to sprints that might be 2 weeks long, a burst could be 4 days. And at the end of the 4 days, the AI is creating the code and all the unit and functional tests you need to validate the code. You bring it into your main build and you're off to the races. And so we have been putting AI in the center of everything that we do in ScienceLogic to radically accelerate our ability to innovate in the platform and deliver faster.
Last question, really, before if you have anything to ask me, Michael, the last question is how much code in the last, say, 12 months that you've seen is actually human written versus it being generated?
Yeah, we actually track this internally at ScienceLogic. Last year, like I said, we weren't using AI to its full capacity. But that said, we measured roughly about 30-35% automation factor, which means that roughly 30-35% of the PRs that were done had some sort of influence from AI. AI was either used to validate or sanitize the code or do hygiene, or AI was used to actually generate the code in the first place. But we expect to get that to be a much higher percentage in 2026.
I think that fair enough. That number is actually encouraging to humans, I think, because a lot other people have spoken to have said it's sometimes a little bit higher for at least newer systems that they're working on building, and it's
Right.
quite the same with us as well. Well, Michael, thank you very much. I'm going to let you have the closing comment, and we've talked a lot about ScienceLogic. So, if in your closing comment, if you could make it generic, not specific to the platform, I would
Sure.
appreciate that. But before
Yep.
we did that, do you have any questions for me?
No, I think we covered a pretty broad surface area, so I'm good, Krish.
Perfect. Thank you very much again, Michael, for your time. Your closing comment before we call this wraps.
I guess my closing comment, and I kind of alluded to it earlier, is that I've been in this I've been in software development for almost 30 years now, and a good portion of that has been around IT operations. And I would say that we are going through a transformation in our industry driven by AI, just like many other industries are getting disrupted by it. But the opportunity to have the machine reason over incredibly vast amounts of telemetry coming off of large IT infrastructure and get to a state that is highly autonomous. And the analogy I use, Krish, is the self-driving car. It's like the Tesla. The point is that if you think about how a car operates, it understands its environment through sensors and cameras and so forth. It's going through some sort of compute algorithm to understand all that sensor data, and then it's taking action in the form of steering adjustments, acceleration, and braking, and so forth. That same exact paradigm exists in the world of IT. Have the machine reason over all the data, understand what matters, take action on it. Obviously, with the human in the loop where it makes sense. Humans got a hand on the steering wheel where it makes sense. But we're trying to enable a platform at ScienceLogic that allows for truly autonomic operation where it's just on autopilot. You can do that. And then where the human exists is going to be driven by company policy.
Lovely. Thank you very much, Michael. And again, folks, definitely, I'm going to include the link. We're going to include the link to Michael's LinkedIn profile and to sciencelogic.com. So do check that out. Appreciate your time, Michael. Until next time. Bye bye.
Sounds good. Thank you.